All right. Hello, everyone. My name is Isaac with Fresh Energy. I'm just going to give everyone like a minute or two to just kind of settle in before we get started so we don't just get rolling before everyone's sat down and everything. I hope you're feeling cozy. Hopefully, you have like a cup of coffee or tea or something so you're ready to settle into some wonky technical details about our latest white paper. While we're waiting for everyone to join, you can go ahead and at the bottom of your Zoom window, you can click on the chat button and feel free to add your name, where you're coming from, your pronouns right in the chat, and we can kind of see where everyone is coming in today. And we have a good list of people that are coming in. But yeah, hopefully you are all ready to dive in for the next hour. It should be interesting. It's a good cloudy day for it. It's been rainy here in St. Paul. It's been raining a lot. So it's kind of a good day to just like sit back and get into some of the details of our latest gas decarbonization white paper. Hopefully the sun is going to be coming out soon. I know I'm really excited for summer and warmer weather, and it's been a crazy, crazy busy spring for us here at Fresh Energy. But it's looking like 11:02, so I think enough people have joined. So I'm just gonna kick it off. Hello and welcome everybody to Fresh Energy's webinar, White Paper Deep Dive, Minnesota's Growing Decarbonization Challenge. My name is Isak Kvam. My pronouns are he, him, and I am the Senior Communications Associate Writer at Fresh Energy. Thanks for joining us. Before we dive into the introductions of the team behind this wonderful white paper, I want to share just a little bit of housekeeping for you all. First of all, yes, we will be sharing a recording of this webinar with everyone who registered. You'll get an email either today or tomorrow with a link to the recording so you can rewatch some of the wonky technical details about this white paper. We'll also be posting the audio from today's webinar to our podcast, Decarbonize, the Clean Energy Podcast, which you can find on your favorite podcasting app. And we'll also add a link to the white paper into the chat right now so you can access that whenever you need as we're going through. Second of all, we'll be taking questions at the end of the webinar during the Q&A section, but you can submit questions during any point of the webinar today by using the Q&A function at the bottom of your screen. Just be sure that if you do have a question, please use the Q&A and not the chat. Feel free to add things in the chat as well throughout, but if you have a question, please do it in the Q&A so that we can be sure to see it and address it. For those of you who are new to Fresh Energy, welcome. Fresh Energy has been working on clean energy and climate policy issues here in Minnesota and throughout the Midwest for over 30 years. We're changing the world through bold policy solutions that move us to a just, carbon-free future. And we're helping everyone who lives here end dependence on fossil fuels, electrify their lives, and build a healthy, clean energy economy where we all can thrive. Okay, let's move on to introductions. I introduced myself just a minute ago, but my name is Isak Kvam. I'm the Senior Communications Associate Writer at Fresh Energy. If you spent any time reading our blog posts or Fresh Energy's emails or mailers, you've probably come across some of my work. That's what I do here. Joe, why don't you go next?
Thanks, Isaac. Hey, everyone. My name is Joe Dammel. I use he, him pronouns. I'm the managing director of our buildings program at Fresh Energy. Curt?
Hi, Curt Nordgaard. Thanks for attending, everybody, and I'm excited to be here today. I have done research on natural gas infrastructure and the composition of natural gas in the past. I'm also a board-certified pediatrician here in the Twin Cities, but I'm here today solely in my role as a consultant with Fresh Energy.
And hi, everyone. I'm Caitlin Eichten. I'm a senior policy associate with our buildings team at Fresh Energy. So I support and lead our regulatory policy and technical work on building electrification and gas decarbonization.
Wonderful. Thanks, Joe, Curt, and Caitlin. Okay, now I'm going to zoom out a bit and talk about why we're all here today. So Fresh Energy is hosting this webinar to dive into the technical details of our newest white paper we recently released about the past and future of Minnesota's gas distribution system. Joe, let's look at it from a high level. Can you tell me about this white paper in a nutshell?
Sure. So the gas system is at a crossroads. It faces challenges from a climate and health perspective, as we're going to hear a little bit more about today. And it also faces challenges from more and more options that are becoming available to electrify end uses. And this white paper lays the foundation about a really big picture of the gas system in Minnesota as we begin to have some pretty significant policy debates about how to make sure this energy transition is equitable, affordable, and reliable for Minnesotans. So we approached this research by trying to answer some pretty big picture questions, really the who, what, where, when, why, and how of the gas system today, and to try to get a better picture of the recent history about how it's grown, and then where it could be headed. So to talk a little bit more about methodology, I'll hand it over to Caitlin.
Thanks, Joe. So our research relied pretty heavily on data that was filed by Minnesota's natural gas utilities with state and federal regulators. There unfortunately was not just one single docket that contained all of this data and information that we needed, but rather the data we were looking for existed across many different federal and state utility filings and dockets. Therefore, our research was an opportunity to coalesce data across many sources to speak to Minnesota's gas system as a whole. And the data sources we used for our research included data filed by gas utilities at the state level with the Minnesota Public Utilities Commission. This included gas jurisdictional annual reports, rate case testimony and work papers, utility rate books, and other natural gas utility annual reporting. We also used data that gas utilities file with federal regulators, which included the Pipeline and Hazardous Materials Safety Administration's annual gas distribution data. And additionally, we used data from the US Census Bureau's American Community Survey. And Joe touched on this a bit, but I wanted to just quickly revisit the main questions that we aim to address as we were digging through all of this data. And these questions included, to what extent are Minnesotans using gas to heat their homes? What is the current state of Minnesota's gas system? Are there any significant trends in the system or in gas consumption and in emissions? And how do building sector's emissions compare to Minnesota's economy-wide goals and other economic sectors? And lastly, what are utilities' plans for replacement of the gas distribution system, and how much will this cost ratepayers?
Okay, so let's shift into high gear here for the main study findings of the white paper, because I know that there is a lot of information to go through. We've gone over some of the high-level summaries of the white paper. Caitlin just talked a little bit about the methodology, so now we're going to get into the data and the findings. So Minnesota's gas utilities provide a wealth of data, and Fresh Energy has been going through it all and piecing it together, trying to pull out the signal from the noise. Let's go through what we learned section by section. Caitlin, do you want to start us off?
Sure, thanks, Isaac. So as a starting point in our research, we looked into the predominant fuels that Minnesotans use to heat their homes. So in this table, we compared the distribution of space heating fuels among homes in Minnesota and in the United States in 2022, which is the most recent data. As you can see, natural gas heats approximately 2 of every 3 homes in Minnesota, making it the predominant fuel used for home heating in the state. And this is higher than the national average for homes heated with gas, which is a bit under half of homes. Additionally, the proportion of housing units heated with propane is also relatively larger in Minnesota, about double the national average. And these two findings are in part a result of the state's relative proximity to natural gas supplies in nearby states and its position as a large importer of Canadian natural gas. And I'll also note that approximately 2/3 of propane supplies are produced from the processing of natural gas. Conversely, the share of housing units heated with electricity and fuel oil in the state are both less than half of the national average, as we see in this table. And lastly, notably, the proportion of Minnesota homes that heat with electricity is higher among renters. So approximately 2 of every 5 renter-occupied households in Minnesota heat with electricity. Next slide. So using the same data, here we mapped the predominant home heating fuel by county subdivision in Minnesota. And as you can see in red on this map, natural gas service covers much of the larger cities and population centers in the state. But at the same time, many parts of the state have no natural gas infrastructure or service. And in those areas, buildings rely heavily on fuels to meet the majority of their heating needs. And these fuels include propane, which is in blue on the map, electricity, which is in that yellow-green color, wood, which is in brown, and fuel oil, which you can see in a few spots, is in orange.
Okay, so we know that natural gas heats most of Minnesota's homes in more densely populated areas, and then propane is used in more rural areas broadly. I live in a rural area north of the cities, and I know that most people around there have propane delivered to heat their homes. So, Caitlin, when you were crunching the numbers on this, what did it show about investor-owned gas utilities?
Yeah, thanks, Isaac. So we have another fun map to show on this slide to answer that question. So most of the homes that heat with natural gas in Minnesota that we saw on the previous map receive their gas service from an investor-owned utility, or IOU, as we also call them, which are regulated by the Minnesota Public Utilities Commission. Minnesota has 5 investor-owned gas utilities and approximately 30 smaller municipally owned gas utilities. And the investor-owned utilities serve approximately 94% of the state's natural gas sales, with the remaining 6% primarily served by municipal utilities. And our research focused on Minnesota's 5 gas investor-owned utilities, which are CenterPoint Energy, which we sometimes abbreviate as CPE, Xcel Energy, Minnesota Energy Resources Corporation, or MERC, Great Plains Natural Gas Company, which we abbreviate here as GPNG, and Greater Minnesota Gas, which is abbreviated as GMG in this presentation. And for this map, we approximated the service territories where Minnesota's 5 gas investor-owned utilities operate based on the lists of communities served that the gas utilities provide in their rate books. And gas service utilities are known for being pretty hard to identify because, unlike electric utilities, they're not publicly defined territories. And I lastly just want to give a big thanks to my colleague, Christine McCormick, who helped me translate all these data into these much more compelling maps using her ArcGIS expertise. So thanks, Christine. So natural gas utilities serve residential, commercial, and industrial customers in Minnesota. This table shows the number of total customers and the number of residential customers by investor-owned utility in Minnesota as of 2022. And as you can see, the state's 3 largest IOUs, which are CenterPoint, Xcel, and MERC, collectively make up 98% of the natural gas investor-owned utility customers in Minnesota. You can also see that residential customers make up a large majority of natural gas investor-owned utility customers in Minnesota.
I actually love seeing where each utility operates on a map, like on the previous slide, because it really helps me picture where these utilities are and then just how big of an area they actually cover. So now that we know where Minnesota's gas utilities are, what can you tell me about the infrastructure they're building and operating within their service territories? Because this was a big part of your research, right?
Right. Yeah. So gas utilities distribute natural gas to customers via a vast underground gas distribution system. There's generally 2 kinds of distribution pipes that transport natural gas within a utility's distribution system, and those are gas mains and service lines. Gas mains are the larger underground pipes that act like a highway for natural gas. So they deliver large volumes of gas to communities and through neighborhoods. Gas mains often run under roads and streets along with other utility infrastructure. Service lines are the smaller pipes that run beneath yards and sidewalks before reaching the building's gas meter, similar to a driveway connecting a home to a road. And then utility-owned gas meters serve as the connection between the service line and the customer's gas piping inside their home or building, which leads to all sorts of end use equipment that burn gas inside our homes, such as furnaces, boilers, water heaters, stoves, and fireplaces. So in our research, we wanted to gain a sense for the size of this underground distribution system. So to do so, we calculated how many miles of gas main there currently are in Minnesota and found that Minnesota's gas distribution system is incredibly large. Specifically, we found that the state currently has over 34,000 miles of gas mains, which means that all of the miles of Minnesota's gas main could circumvent the Earth about 1.4 times. This table shows where the total miles of gas mains by utility in Minnesota compared to the circumference of Earth for each utility. So for example, CenterPoint's gas mains alone would reach approximately 60% of the way around Earth. Also, 90% of the total gas main in Minnesota is owned by investor-owned utilities, with the rest owned by municipally owned gas utilities.
Wow. So I imagine that that is a lot of infrastructure to not only build, but then also maintain over time. Has the system of gas mains and service lines always been this large in Minnesota?
So if we look back over the past decade or so, we see that Minnesota's gas system has grown pretty steadily. This figure on this slide shows the growth of natural gas mains in Minnesota, specifically the gas mains that are owned and operated by the 5 largest gas utilities. We see here that the total miles of gas mains in Minnesota has risen steadily year over year, mainly due to connecting more and more customers to the gas distribution system. And this trend is concerning because every mile of gas main that is built represents a pretty substantial investment in both cost and in time, with many new gas pipes planned to be used and paid for as long as half a century into the future. And since utilities recover their financial investments over time, every new mile of gas main also represents a potential commitment to burn gas for over a half a century while utilities recover their investment costs. So in other words, a gas main installed in 2024 could still be in service in 2074, and customers could still be paying for it.
Okay, so we can see that gas mains are rising steadily year over year. Are service lines that connect buildings to those gas mains also growing?
Yes, yeah. As you'd expect, the total number of gas distribution service lines owned and operated by the same utilities have correspondingly increased over time, as you can see in the figure on this slide.
So Caitlin, when you're looking at these figures, you can really see just how huge our state's gas distribution system has grown. Curt, I know you specifically looked into what that big growing gas distribution system means when it comes to gas sales and then corresponding greenhouse gas emissions. Can you tell me what you learned?
Yeah, that's right, Isaac. So as we've just seen, the physical component of Minnesota's natural gas system has been growing. And so we next asked the question, what about the gas being delivered by that system? And to answer that question, we again went back to filings from the utilities with the Minnesota Public Utilities Commission. And in different reports, what the utilities provide are gas sales. And for this analysis, we equated gas sales or gas deliveries with gas consumption. And you can think about that as if you deliver a unit of gas into a building, that gas gets used or otherwise processed in the building. So when we look at those data, we also compared them from year to year, and you could say, well, but some winters are colder than others, so we would expect gas sales to be going up and down based on the weather. And actually, each of the utilities that we looked at will normalize their own data based on historical weather. And so they do that through a proprietary calculation on their part. They also do a proprietary calculation to project how much gas they expect to deliver going into the future up through 2038. And what we'll see for the slides that I'm going to talk about is that it actually is not the 5 utilities, but 4 of them, because these are the 4 that are required by the state to both report the gas sales, historical sales, and to project sales into the future. So now looking more carefully at the figure, the units here we see are decatherms, and that's a common unit in the natural gas industry. It may not make sense to most people though, so one other way to think about a decatherm is that it's pretty much equal to 1 million BTU, or British thermal units. And for a residential home, a natural gas furnace may be on the order of 50,000 to 100,000 BTU. So that can give you some frame of reference for these units. And we started again with 2010. And for these data, every 3 years, we assessed the gas sales through 2022 and then through 2038 into the future, 2033, 2038. And what you can see is the same trend that we saw with the physical infrastructure is also there for the gas sales data. That in 2010, we were a little over 150 million decatherms. And through 2022, the most recent year that we have data for, there's been regular growth when you take into account changes in the weather. And that not only is that the historical trend, but there's a pretty similar trend going forward into the future projected by the utilities. We could have some discussion later about what those projections mean and where they come from, but I'll just say here, these are the projections utilities filed as of 2022 with the Public Utilities Commission. And so we felt these were the most appropriate or the best data we have to look at where utilities see their future gas deliveries going.
Okay, so we know from gas utilities' own data that as we build a bigger natural gas distribution system, we see that gas sales go up as well. That makes intuitive sense since more customers are hooking up to the gas system and then using that gas. So Curt, why don't you tell me about why we care about natural gas sales? That's a problem for Minnesota's greenhouse gas emissions, right?
Right. Yeah, as a fossil fuel, either burning or in the case of natural gas, releasing it in the environment does release greenhouse gases. And so what we did to try and understand the greenhouse gas emissions from Minnesota's natural gas use in buildings, we converted the sales in decatherms to tons of CO2 emitted. And first I should say, I didn't mention in the last slide, but the data that we looked at for sales were for residential buildings and commercial buildings. And that could be, as we heard from Caitlin, for any use within that building. And so we're looking at the same numbers here now for CO2 emissions. We assumed that 1 unit of gas being delivered to a building, either residential or commercial, is going to be consumed and produce a certain unit of or amount of carbon dioxide emissions. And that's a very different number than if you were used to thinking about appliance efficiency. This is not the kind of number we're talking about here. We're talking about a unit of gas that's completely used up. And we did that conversion using a conversion factor from the US Energy Information Administration, a standard conversion for burning gas producing a given quantity of CO2. So, as you can see, the same trend holds, and that's because if you have 1 unit of gas producing a certain amount of CO2 and then you multiply that by 100, you get 100 times the amount of CO2 produced, so there's a linear relationship. And we see that same trend that in 2010, the use of natural gas in Minnesota's buildings resulted in nearly 10 million tons of CO2 emitted. And that number goes up consistently in direct relationship to the amount of gas being delivered to buildings, such that in 2022, the buildings in the state released, in our estimate, 12 million tons of CO2, and that's expected to go up through 14 million tons by 2038 at the projected rates that we were looking at.
So Curt, you're telling me that according to gas utilities' own data, they're expecting greenhouse gas emissions to grow over the coming decades, not decrease like we need them to meet our state decarbonization goals. So what did you learn from the data for how emissions from buildings compares to our other sectors where Minnesota is reducing emissions?
Yeah, and actually, if we could go back a slide, I just want to make sure the audience can see that the state has set goals for emissions reductions from buildings, and those goals were prepared under Minnesota's climate action framework, and they're not requirements or mandated, but they're meant to set us on track to reach the state's overall greenhouse gas reduction goals. And so the red dotted line here, what we're seeing is the amount of CO2 that we have as a goal for 2035. And that's for burning fuels in buildings, all fuels, not just natural gas. So you can see that in 2010, we were already well above that goal, of course. But because of the growth in gas delivered to buildings and CO2 emissions from buildings, we could be nearly double that goal by 2038 if these projections hold true. So if we compare to other aspects of the economy, we can make these comparisons to try and understand, like, what does this mean, these tons of CO2 we're talking about? It's not just abstract, there's a real meaning here if we compare it to our state's climate goals. So if we look at the next slide then, this is comparing emissions from buildings with our emissions from the entire economy. And in order to make that comparison, we're not looking at tons of CO2, we are looking at percentages. So we're considering 2010 as a baseline year, and that's 100% as the baseline. The blue line is the tons, or the relative change in CO2 emissions from Minnesota's economy across the state. So that's all economic sectors. And starting with that line, what you can see is after 2010's pretty much stayed level for a few years, and then over the next few years, going to 2019, there's been some decline in the state's overall greenhouse gas emissions, which is great. And then looking ahead to the next points in that blue line, 2025, 2030, 2050. These are goals for Minnesota's statewide emissions that were set by the legislature under the Next Generation Energy Act. The legislature updated those goals in last year's session so that we now have a 2050 net zero goal. And what you can see, just focusing again on the blue line, is that this recent couple of points in the historical data are actually laying out fairly well with the direction the legislature has set for us to reach net zero by 2050. So that's the good news. The bad news is if you look at the red line, these are the same emissions we looked at the last slide, but again, converting them to percentages. And you can see going from 2010, that percent change is going up every year instead of going down, such that by 2040, we could see over 40% increase in emissions from buildings if the utility projections really carry through. And one thing that's really easy to see from this figure is that compared to the state's overall direction going down, the emissions from buildings, both historically since 2010 and going into the future, they're going the wrong direction. That's pretty easy to see here.
That makes sense. So we can kind of see that emissions from buildings is growing when it really needs to be decreasing in order to meet Minnesota's emissions reduction targets on the blue line. So I'm curious, how do those building emissions compare to other sectors? Because historically, our electricity generation sector had by far the most greenhouse gas emissions, but we've actually made a lot of progress there in reducing emissions. And those emissions themselves have decreased by a lot, correct?
Yeah, that's definitely true. And for this comparison, we picked the electricity sector as a comparison because of what you said. We have good data for the sector. And I think for a lot of us, it's easy to think about electricity generation as being a dirty industry in the past where we were burning coal, we have dirty power plants that are burning fuels to make electricity in the state. And so if we look at the next slide, we're doing another comparison here, but this time we're looking at absolute tons of CO2, not percentages. And so starting with in 2010, Minnesota's power plants released nearly 50 million tons of CO2 that year, which is quite a lot. And not surprisingly, as we've deployed more renewables in the state, the emissions from generating electricity have fallen nicely, such that by 2019, we're down to nearly 30 million tons of CO2 per year, which has been great progress. If you look at emissions from buildings during that time, you could say, well, look, they're so much lower. The red line here is a lot lower than the blue line. But there's, instead of this pretty substantial decrease, again, as we've been talking about, there's been a pretty gradual and consistent increase in emissions from buildings. Now, the Minnesota legislature, as of last year, also passed a carbon-free electricity standard, which says that any electricity used in Minnesota needs to come from carbon-free sources by 2040. So that's a great goal. The 2030 and 2035 points in that blue line for the electricity generating sector are midpoints for us to reach that 2040 goal. And you can see, comparing our goals for the electricity sector to where we've been historically, they also line up fairly well. The legislature is just requiring the electricity sector to continue the trends that have been going on for the last decade or so. And that'll get us to net zero by 2040. Now compare that future trajectory with buildings. And one of the things you can see is that the two lines intersect. And what that's telling us right away is that at some point buildings, if historical trends continue for both sectors, buildings will become a larger source of emissions than generating electricity. Not only that, where do they intersect? What's the year where we think that could happen? And that's going to be no later than the end of this decade, according to the data that we looked at from the Public Utility Commission filings by the utilities. So that's pretty striking if we stop and think about it. No later than the end of this decade, that's 5 or 6 years. When we look at those numbers, those emissions data, buildings and just burning gas in Minnesota's buildings could be a larger source of emissions than all of the electricity that's generated in Minnesota.
Okay, so that's kind of one of the main problems that the white paper brings up. In order for Minnesota to meet its decarbonization targets, we need to be decreasing, not increasing, greenhouse gas emissions from the building sector. I'm really curious, did you also look into how a growing gas system increases not just emissions, but also costs as well?
Yeah, so it's important to understand, so as we've described, Minnesota's gas system is expanding in terms of infrastructure and gas deliveries. And at the same time, Minnesota's gas utilities have also accelerated the replacement of the existing system over the past decade. So as a result, utilities have replaced much of the oldest, leakiest, and therefore riskiest pipe material in the system, like cast iron. Going forward, gas utilities continue planning to spend on these accelerated replacement projects, moving on to other older legacy pipe materials such as steel and plastic pipe. And these infrastructure replacement efforts will have significant rate impacts for customers as utilities seek to recover the costs of these expenditures through customer rate increases, either via rate cases or rider proceedings. So for example, in 2022, CenterPoint's capital expenditures were approximately $415 million, with distribution expenditures making up almost 90% of that total. And as shown in the figure here, CenterPoint is planning to invest over $1 billion customer dollars to replace existing pipe over the next 3 decades. And we pulled this information on CenterPoint's main replacement projects, which include legacy plastic pipe, bare steel, and legacy steel, from work papers for CenterPoint's integrity management program in its most recent rate case.
It's a good thing to replace old risky pipes that leak, of course, but this really shows that when we're investing in a growing gas distribution system, we're also going to need to reinvest over time to update that system. Are there any other challenges you see that's associated with a growing gas system?
Yeah, so I'd say that the challenge with replacing existing gas infrastructure is kind of a threefold challenge. First, replacing pipe generally increases costs by growing rate base, but does not add new utility customers who can provide additional revenue to offset those costs. The second challenge is that new utility pipe has an expected useful life of decades, which runs well beyond Minnesota's 2050 goal for net zero greenhouse gas emissions. And this means that we'll be paying for replacement projects well into the latter part of this century, when Minnesota's building sector emissions should be net zero. And the third challenge is that utilities do have a fundamental obligation to provide safe and reliable gas service, and an important part of that obligation necessitates continued investment in the system for the foreseeable future. So together, these three challenges present risks for current and future customers and the public at large. Current customers face ever-increasing gas service rates that impact energy-burden customers the most acutely, and future customers face the risk of increasing rates driven by capital spending and fewer customers, across which these costs can be spread due to increasing electrification of the heating sector.
Let me unmute myself. So 1, replacing pipe is expensive. 2, we're investing in a multi-decades long system that needs to not be polluting in 2050 in order to reach our climate targets. And then 3, utilities still have to keep the system upgraded for safety. Those are 3 really tricky challenges to hold all at the same time. And I imagine that those also have cost implications when we're looking ahead, correct?
Correct. So as electrification of the heating sector increases over time, the public faces the risk of addressing utility assets that are not fully depreciated, which but are also not being utilized due to customer defection from the gas system. And these are also known as stranded assets. So this table shows the average rate base reported by the investor-owned utilities for 2022. And rate base is essentially the unrecovered gas distribution infrastructure, so the mains and service lines, et cetera, and therefore represents the potential stranded asset risk in the future.
Okay, thank you, Caitlin. That was a very helpful and very wonky look into the details of this white paper. Thank you, Curt and Caitlin. Joe, I'm wondering if you could summarize this entire white paper so that folks can easily recall what the most important things to remember are. How would you summarize it?
Thanks, Isaac. There's a lot to summarize, and I'll try to put that into a nutshell. So the gas system is big, and it's getting bigger. And so just think 1.5 times around the Earth big, and that's pretty big. And it's steadily growing every year. Similarly, gas usage and emissions are also projected to increase over the coming years. And that's happening as emissions from other sectors like the electric sector decrease over that same time. So gas emissions stand to make up a larger share of state greenhouse gas emissions if nothing is done to change the current trajectory. Gas utilities are also more than a decade into accelerated replacement programs that, as Caitlin mentioned, are replacing the oldest, leakiest pipes on the system. But those replacements have a useful life of 40, 50, 60 years into the future. And Caitlin also talked about how that poses a potential stranded asset risk as we change how we heat over that same time period, and hopefully sooner. So all of these findings really point to the current trajectory of the gas system being really incompatible with state goals, and all representing challenges and stresses to the utility system that customers ultimately feel. To really wrap it up, I want to give a shout out to the work that Caitlin and Curt did to put this all together. As you've seen, it's all publicly filed information, primarily generated by utilities themselves, but it's information that's scattered throughout state and federal agencies. And I think the novel part of this white paper is really bringing all of those pieces of data together, because it really forms a compelling narrative about the gas system today and where it could potentially be heading. And I think it also opens up some really good data points for future policy discussions that can help reverse those trends that we're seeing. So I think it's really important work of collecting and analyzing and telling that story.
And I'll just jump in here and say thank you to Joe for leading a lot of this work. And also, I'll share some news for folks who haven't heard that Joe Dammel will be leaving Fresh Energy at the end of this week to take a position with RMI, or the Rocky Mountain Institute. We're definitely going to miss him and his leadership here on the Fresh Energy Buildings team, but we're also very supportive and excited for the next chapter in his career. So thank you, Joe. But that also means that we have a new job posting available at Fresh Energy, which I'll get to in a second. But first, I want to wrap up our webinar for folks who won't be able to stay for the Q&A section. I hope that for those of you who were able to join us today, you're feeling a little more informed about the details of this white paper and how Minnesota's natural gas distribution system poses an interesting problem for meeting our state's decarbonization goals. People listening might be wondering what's next for Minnesota, how we're going to tackle this problem, and how they can learn more. Well, first, you can sign up for the Clean Heat Minnesota Coalition. This group launched last fall, and it's led by Fresh Energy, Copal, and Club Minnesota. This coalition is made up of both individuals, but also organizations. In fact, over 30 organizations have already joined the coalition. So you can learn more about signing up as an individual or a group at cleanheatmn.org or by scanning that QR code. Second, if you feel motivated to get gas out of your own home, Fresh Energy has created a super helpful, high-level resource that helps Minnesotans navigate the many, many federal and state tax incentives and rebates for electrifying your home. You can see this guide at electrificationandyou.org. And then third, I know the development team would definitely want me to share how important our donors are. So as you may know, Fresh Energy is a nonprofit that relies on individual donors to make our work happen, just like the white paper you've just learned about. You can support our work by making a donation today. Big or small, you can get the details on the QR code that's right on the screen here. And then, as I alluded to before, the last thing I'm excited to mention before we get into the Q&A is that Fresh Energy is hiring a managing director of buildings. If you're interested at all in what we've been talking about here today, you're probably an excellent candidate for this role. You can visit freshenergy.org/job openings to see the job posting. And right now, if you just go to our homepage, it's right there at the top of our website as well. And you can always see it on the Join Our Team webpage we have set up too. Okay, we are going to move into the Q&A section for those of you who can stay on for the remainder. I'm loading up the questions here. I think let's start with the first one. This one's for you, Curt or Caitlin, I believe. And the question is, in all the data that you just shared, what did you find to be the most surprising to you?
I can jump in. I guess I was first surprised at just the wealth of data that exists that I don't think stakeholders are often aware of, because it's not like advertised and it exists in all these different filings at federal and state level, and it could be pretty tricky to locate and interpret those data, but it's really useful data for providing context for the kind of more important discussions about policy solutions. And then once we had our hands on all of this data and did the work of analyzing and interpreting it, I was surprised by many of our findings. I was surprised at how kind of large the current system is, especially when you can compare it to something like the circumference of the Earth and just the historical growth of the system. It's also relatedly kind of surprising. And then to see utilities' projections for the ongoing growth and increasing gas deliveries into the future when we need to be reaching our state emissions goals, as Curt mentioned. And then lastly, just the accelerated replacement of existing gas pipeline that utilities are planning for as far out as 2055, as we saw in that one figure, when we really need to be at net zero for greenhouse gas emissions as a state, which raises some big concerns for achieving an equitable energy transition and presents pretty large stranded asset and cost recovery risks.
Yeah, a couple things about the data that stood out to me or surprised me. And one is the consistency of the trend in terms of growth of gas sales. So once you take away the impact of weather, it's actually surprisingly consistent to see the growth in gas delivery. That I wouldn't have expected. The other thing is, again, the comparison of emissions from our buildings that burn natural gas to the electricity sector. We're just so used to thinking about like, that's the big one you got to go for to fight climate change is, get rid of that coal and dirty power plants. It won't be long. It's gonna, I think, be shocking to a lot of people when that point comes, because these are slow moving boats. We can't just turn that system around in 2 years. And we're very likely to reach a point soon where that's going to be in the headlines. And I think that's going to be surprising for a lot of people. And I know it was for me.
That makes sense. I have a question from Luke here. I'm not sure which one of you three wants to answer, but the question is, have any of our Minnesota investor-owned utilities made public, quantifiable, Minnesota-specific goals for reducing their customers' greenhouse gas emissions?
Yeah, I was just looking at that question. I think, and others feel free to chime in here, the closest thing I've seen to that is Excel's net zero vision for gas in Minnesota. I'm not sure if it's that quantifiable, but I think that's the only gas utility I've seen with a specific goal in writing.
Yeah, and I believe CenterPoint has a similar but distinct goal. I wouldn't want to speak to it without having it in front of me here. I think I answered another question about decarbonization plans from utilities in the written Q&A. And thank you, by the way, for everyone who have been submitting questions. There's a lot of really good ones here. So NGIA, the Natural Gas Innovation Act, can be a vehicle for decarbonization and emissions reductions from gas utilities. I think it is similar to a clean heat plan that states like Colorado have, and that requires gas utilities to reduce emissions by a certain amount through these plans. The NGIA doesn't work exactly like that. It requires reductions in geological gas throughput and reductions in greenhouse gas emissions, but doesn't put a target on it. So that's a distinction there.
I'm going to loop together a few questions here, and you guys have kind of touched on this in the Q&A a little bit, but I'm still going to ask. Some people are wondering about the service areas for IOU gas utilities, and they're wondering what governmental body explicitly defines the service territory for different IOUs, and then how it works when there's, say, a new development in a new area. How is it like considered who will supply gas to that area?
Sure, I can take that. And I can build a little bit and repeat some of the answer that I gave in the written answer for folks who haven't been tracking that. So unlike electric utilities, and this is maybe surprising for folks, unlike electric utilities in Minnesota, there are no defined gas service territories for gas utilities in Minnesota. So I know there's like maps of electric service territories, and the Public Utilities Commission ultimately approves those maps. There's not that same gas utilities. The policy behind that is really that the PUC has determined that competition for customers can help all customers in terms of reducing the cost of serving brand new customers. It usually, I don't think it's like a constant battle between gas utilities for a new customer. Oftentimes the gas utilities that offer to serve that customer have existing service in that area, and it's just expensive to build out a brand new gas main, especially given the connection or lack thereof to the interstate pipeline system where we get all of our gas from, since we don't have any gas production in Minnesota. But it does happen from time to time. Maybe 5 or 6 years ago, there was a large building, a practice facility that a Minnesota sports team was building, and one gas utility ended up serving that customer when another gas utility was planning to serve that customer. That dispute got brought to the Public Utilities Commission, and it's actually a really interesting discussion about this very concept about competition amongst gas utilities, the policy rationale behind it, and ultimately, weighing the benefit to all ratepayers of having that sort of healthy competition in the marketplace. I think that the questions about serving new customers or new communities brings in two types of policies that govern extensions. And so one that we may have heard about is gas line extension allowances. So that, and I think we might have a blog on our website about that. But it's basically when a new customer or group of customers in a development wants to connect to an existing gas utility system, the gas utility will provide an allowance of, we use feet in Minnesota, other states use a dollar amount. So roughly right now, and it's not uniform across gas utilities, but you'll get about 100 feet of gas main for free that basically every ratepayer pays for, and 75 feet of service line for free, which again is free to that customer, but everyone pays for it. Anything above that customer is responsible for payment. And it's really intended to provide a benefit to all ratepayers by adding new load. And that's been a really long-standing policy in Minnesota and across the country to build out the gas system. Other states have started to rethink that policy, both at the legislative level and at the public utilities level, even removing gas line extension allowances entirely. That doesn't mean that that state, by doing that, is banning the connection of gas. It's really just shifting some of the costs onto the brand new customers. We also have pro-expansion law that helps communities join the gas system. So the new area surcharge and the natural gas expansion project rider are two laws that the legislature has passed that help communities join the gas system. And both of those were enacted under or following, severe winters, polar vortexes, propane shortages. And so are really intended to connect folks to what was at the time a really reliable, affordable energy service. And so we think that there are other technologies now that can exist, or that do exist, that can also help connect communities to reliable, affordable, clean heating sources. So we're starting to see more and more network geothermal and thermal energy network pilots being proposed, both by utilities and also by cities. So we think it's really important to provide Minnesotans with clean, reliable heating. And we think that just the ways that we can do that now and achieve those goals are really changing.
Perfect. Thanks, Joe. And speaking of cleaner heating, I have a question here that says, it's describing how our white paper looked at more customers are being added to the gas system, and so we expect emissions to increase over time. But then at the same time, we're also seeing homes are becoming more energy efficient, appliances that use gas are also becoming more energy efficient, and then increasingly more Minnesotans are switching to cleaner electrified ways to heat and power their appliances. So how does that square with the white paper? How do we see those emissions changing? Did the white paper consider that?
Yeah, we actually did that analysis, and we do have a figure in the white paper that addresses this question. We just couldn't fit it into the webinar, but I'll try to summarize it here. So when we pulled the data on gas deliveries, we also included the data on the number of customers served for each of those quantities. And so we were able to perform our own calculation using heating degree days from the National Weather Service. And we did our own normalization, taking into account variations in weather, just the same way that utilities did, but maybe a different calculation than the way they had done it. And by using all of those numbers together allowed us to say, for a given unit of heating demand, how much gas was a given customer using. And so that we did look at that over the same study period of 2010 to 2022. And it's a little bit different than I think other ways that the state tracks energy efficiency. So we were literally looking at what are the utilities data showing us about that gas use or the energy intensity of our buildings. And those numbers are completely flat during that period. So there may be energy efficiency gains, and those might be more on the electricity side with things like LEDs. There may be some efficiency gains, like maybe there are 95 whatever efficiency furnaces, but maybe we're not installing enough of them to really make a difference. There are other explanations. If you make your home more energy efficient, some people might say, well, now I can afford to boost the thermostat up so their total natural gas consumption stays flat, even though their efficiency of their home went up. So there are a lot of ways to think about those data, and they're quite interesting and complicated. But we did look at it, and from what we can see using this approach is that we haven't really made any progress. So we can't expect that to be the solution in the future unless we do something very different than how we've approached efficiency in the past.
Yeah, and I'll just add too, I think that's a really important disconnect that I think the white paper highlights, and I think it's one of the important aspects of the white paper, again, bringing in utilizing utility data and really from disparate dockets or filings, and really calling into question like overarching trends that we're seeing from gas sales and trying to square that with what we might expect to see, because we do have really strong energy efficiency and conservation programs in Minnesota. We've had them for 30 plus years, and they're continuing their evolution to include things like fuel switching in this latest version of the programs. And so we know we're doing a really good job on that, but we're still not seeing the change that we might expect to see in the data itself for a number of reasons that we just weren't able to explore that Dr. Nordgaard just mentioned. So I think that's one of the benefits that we saw of doing this, is really uncovering those disconnects and trying to figure out what was really driving it.
I think we have time for one more question here, and this is kind of a technical question about how we calculated our greenhouse gas emissions. So I think this is going to be in your court, Curt. But the question is about how New York uses a 20-year time frame for greenhouse gas emissions, which takes into account the fact that methane traps a lot more heat over 20 years than CO2 does. And they're wondering how our calculations kind of incorporated how methane acts over 20 years and then over the longer period as it's oxidized into CO2. Curt, I think I've heard you speak about this before, so I think this is your territory, if you can sum it up in about a minute.
Yeah, this is a very good question, and it gets at how we converted gas sales to CO2 emissions. And this question is really pointing to whether we did a more comprehensive, almost like a life cycle assessment of the emissions. So the leaks from the distribution system, or the LDC that was used in the question, but also appliances within buildings leak. And so the source, that's important, the leaks from the distribution system in buildings, because when the natural gas gets up into the atmosphere, of course, we probably mostly know, all of us here, that it's predominantly methane, and until it becomes oxidized to CO2, it will have a greater impact on warming. And so the way that's usually handled is to estimate the warming impact by using a CO2 equivalence. And so like the EPA does that for a lot of their work with natural gas. We didn't do that. And partly because it would have complicated the analysis, and it also, for that extra complication, we wouldn't have gotten a very different answer, I think, because of the natural gas leakage rate in Minnesota from the distribution system and from buildings. So if anything, if we had done that analysis or taken those data into account, whether we use the 20-year horizon or the 100-year horizon, we would have actually seen that the numbers would have looked worse than they do right now. So we're kind of like giving it like a best showing, like if we only look at the gas that got burned and assume everything's getting burned and nothing's leaking. That's what we see here, which is already not great. If we did that extra number crunching analysis, then it would have looked a little bit worse.
Okay, thanks, Curt. And thank you, everyone. We're about at time, so I'm going to wrap up. Thank you so much for coming to our webinar today. As I mentioned earlier, we'll be emailing a recording of this webinar to your inbox later today or tomorrow. I'd like to thank Joe, Caitlin, and Curt one last time for leading us through this white paper and helping us understand more about Minnesota's gas system. Have a great rest of your day, everyone. Thanks for joining us.